tangent planes and normal lines. First problem is as follows. You're given this equation, x plus y plus z equals 4, and you are given a point on this plane. Remember, a number times x plus a number times y plus a number times z equals a constant. That's the equation of a plane. In our case, a is 1, and b is 1, and c is 1, and d is 4. And you can verify that it works. 2 plus, that is, this is a point on a plane. 2 plus 0 plus 2, it really is 4. And give you some figure advice. If you're taking an exam and that doesn't work out, don't do the problem. Say it's not valid. That way you get all the points. Well, first show it's not valid. Show that 2 plus 0 plus 2 doesn't equal 4. And then you say you can't do it. This point's not even on the plane. Now what is the instructions? Find the unit normal vector to the given surface, which is this, at the indicated point. So it's just the gradient again. We want to normalize the gradient. We want to make it of length 1. Y, Z. Well, I hope you realize that the gradient is just 1, 1, 1. What you can do is you can say that f of x is x plus, in here it should say x, y, z. F of x, y, z is x plus y plus z, say minus 4 equals 0. The minus 4 is not doing anything. The partial of this with respect to x is 1. Y, 1. Respect to z, 1. Okay. Alright. With respect to x, the derivative of 1x is 1, the derivative of y is 0, and the derivative of z is 0. So that's why I had 1. 1 plus 0 plus 0 is 1. With respect to y, the derivative of x is 0, plus the derivative of y is 1, plus the derivative of z is 0, and of course the derivative of constant is 0. This is 1. So we have the gradient, okay? We have the gradient. But we want the gradient at our point. We want the gradient not at just any x, y, z, but at 2, 0, 2. 2, 0, 2. Well, when x is 2 and y is 0 and z is 2, 1 equals 1. When x is 2 and y is 0 and z is 2, 1 is 1. When x is 2 and y is 0 and z is 2, 1 equals 1. Okay, and all we want is the length of this. The length of this is the length of that, which is 1 squared plus 1 squared plus 1 squared square root, square root of 3. Except, like I said, we want to normalize it. We want to normalize it. So what you get is, now remember that 3 is the square root of 3 over 3. It's the square root of 3 over 1, actually. The square root of 3 is 3 over the square root of 3. So I'm going to take my vector 1, 1, 1, and I'm going to make the length 1 by dividing by 3 over the square root of 3. And if you prefer, you can put the constant right in front. And there it is. There's no magic here. What you need to know is that when they ask you this type of problem, and this is how you study. You don't even have to work out problems only. One of the ways you study is if they give me an equation and a point, and they want me to find a unit normal vector to that surface at that point, I find the gradient, and I convert their lengths to, I normalize the lengths. I normalize the vector. Normalize means you make the lengths equal 1. If somebody gives me the vector 3, 4, 5, and they say normalize it, well, I compute this. I know that's 5 squared plus another 5 squared. Now, rather than adding them, you should get in the habit of saying that it's 25 times 2. Because if you have the same number, you know the square root of that number. That's friendly. Because the square root of 25 is 5, and the square root of 2 I don't know. So now remember, this is the same as 5 times 2 over the square root of 2. It's 10 over the square root of 2. So I divide by 10 over the square root of 2. This vector is length 1, has length 1. It's a unit vector. I normalized it. I made the length 1. They tell you that the length of x over y minus z is 0, and the point is 1, 4, 3. And they ask you same question. They ask you to find a unit vector to the given surface at the indicated point. That means normalize the gradient. So I'll just define this to be f of x, because it already equals 0. But since it's ln of a fraction, I'll do ln of the top minus ln of the denominator. It's a lot easier. So now f sub x will be, that's just 1 over x minus 0. F sub y would be, well, this is a constant, has no y's. It just has y. So it's y minus z in the bottom and the derivative on top. And then with respect to z, you put the this is a constant, it's 0. Minus the derivative of this. You put y minus z in the bottom, and the derivative of y minus z is negative 1. So that actually becomes plus 1. Now, I don't know why I wrote it this way, but it's no big deal. I mean, the gradient of f of x, y, z is the partial with respect to x, comma, the partial with respect to y, comma, the partial with respect to z. Okay, now let's find the gradient at our favorite point. 1, 4, 3. X is 1. 1 over 1 is 1. Y minus z. 4 minus 3 is 1. Negative 1 over 1 is negative 1. Y minus z, we just said it was 1. Okay, 1 over 1 or 1. Okay, the length of this, is 1 squared plus 1 squared plus 1 squared. The square root of 3. which is 3 over the square root of 3. So I take my vector 1, negative 1, 1, and I divide by square root of 3 over 3. That is, I multiply by the reciprocal. Dividing by a fraction is the same as multiplying by the reciprocal. And there's the answer. Okay, again, no magic there. But you need to know, when they ask you that question, you need to know to find the gradient, calculate the length of the gradient, and then divide by that value. Take the gradient and divide it by its own length. Now they want us to find an equation of the tangent plane to the given surface at the indicated point. Find the equation of the tangent plane. Given the function f of xy, which means z, equal 25 minus x squared minus y squared at the point 3, 1, 15. So first we want to find fx. And then we want to find fx at 3, 1, 15. And then we'll find fy. And then fy at 3, 1, really just 3, 1. Okay. The derivative of this with respect to x is 0. The derivative of that with respect to x is negative 2x. And the derivative of this with respect to x is 0. When x is 3 and y is 1 and z is 15, this is negative 6. Now, if you see the symmetry again, if you interchange x and y, you get the same answer. The fy, it will just be, instead of x, I'm going to put y. And if you check it, it's right. Negative 2 gets multiplied by the y value, which is 1. That's negative 2. This is, these values are like the slopes. What you get is negative 6 times x minus the x value plus negative 2, which means minus 2 times y minus the y value plus 1 times z minus the z value. Think about why the z minus the z value gets multiplied by 1. And this is equaling to 0. Say you get negative 6x minus 2y plus z equal. I'm going to bring the constant to the other side. Positive 18 goes to the other side is negative 18. Positive 2, negative 2. Minus 15 plus 15. You get negative 6x minus 2y plus z is negative 5. There is one problem. There shouldn't be one. It's kind of obvious. I'll even say why. It should be negative 1. So it becomes, when you distribute, it becomes negative 1, z. Plus 15, so when it goes to the other side, it's negative 15. Which gives me negative 35. And I would now multiply everything by negative 1. Okay. Now, possibly what we should have done was, we had that z is equal to 25 minus x squared minus y squared. If I bring the z over, I get my 0. Minus z. Okay? And I probably should have done an f sub y. And f sub y is just negative 1. And I meant to say f sub z. F sub z. And since it's a constant, f sub z at 3, 1, 15 will still be good old negative 1. That is why there's a negative 1 there. This here is the equation of the tangent plane of that surface at that point. You find f sub x at the point, and you multiply it by x minus 3. You find f sub y at the indicated point, negative 2. You do negative 2 times y minus 1. F sub z at the point is negative 1. You go minus 1 times z minus 15. And what I equals 0. What I said is right there. That's the equation of the tangent plane. Okay, let's do this again. Find the equation of the tangent plane. Equation is this. And the point in question is 2, negative 2, 4. So first you should really get it equal to 0. F of x, y, z. Think of this bringing the 36 over. Is x squared plus 4y squared plus z squared minus 36 is 0. Oh, f sub x is just 2x. The other terms have no x's in them. F sub y is only this term has a y in it. It's 8y. And f sub z, 2z. But f sub x at 2, negative 2, 4. Well, when x is 2 and y is negative 2 and z is 4, that's 2 times 2. Or 4. F sub y at this special point is multiply 8 by the y value at negative 16. Multiply 2 by the z value and get 8. Okay. So it's 4 times x minus the x value minus 16 times y minus the y value, which makes it plus 2, plus 8 times z minus the z value of the point. This is 0. So we have 4x minus 16y plus 8z equals negative 8. Bring it to the other side, it becomes plus 8. Minus 32, the other side plus 32. Minus 32, the other side plus 32. So 4x minus 16y plus 8z is equal to 40, and 32 is 72. I'm going to divide everything by good old 4, because that's the largest number that went into all of them. Get x minus 4y plus 2z equals 18. Minus some silly error, that is the equation of the tangent plane to this surface at that point. Now we want to find an equation for the tangent plane and find symmetric equations for the normal line to the given surface at the indicated point. So we are given the equation of some surface. And here's our indicated point. Like I said, first we want the equation of the tangent plane. So we define a function f of x, y, z to be x squared plus y squared plus z minus 9 is 0. So f of x is, well, it turns out that each of these functions, except for the 9, which is a constant, and this is the only function of x, that's the only function of y, and that's the only function of z, which makes life easier. You get 2x. For y, the partial is 2y. For z, the partial is 1. Okay, at the indicated point, well, in this case, it didn't have to just have x's, but it just had x's. S of x only have x's. X is 1. 2 times 1 is 2. Y is 2. 2 times 2 is 4. And regardless of what x, y, and z are, 2 equals, 1 equals 1. So now that we have these values, it's a piece of cake to write down the equation of the tangent plane. It's 2 times x minus 1 plus 4 times y minus 2 plus 1, which I won't write, let me write it, times z minus 4 equals 0. That's the equation of the tangent plane. You can clean it up. 2x plus 4y plus 1z is equal to negative 2 on the left side, but I'm bringing it to the right. Negative 8 plus 8. Negative 4 plus 4. This adds up to 14. So 2x plus 4y plus z is the number 14. And that is the equation of the tangent plane. Now, it also wanted us to find the symmetric equations for the normal line to that surface. Well, the numerators are easy. It's x minus the point, which is 1, y minus the point value or the y value, and z minus the z value, which is 4. And this gets divided by the f of x numbers. I mean, the the partial, fx, fy, fz. 2, 4, 1. Done. You need to know what to do. You need to be walking down the street saying it. If they want me to find the equation and the symmetric equation for the normal line, I'm going to find fx at the point, fy at the point, fz at the point, and then I have my point. My point is f0, y0, z0. The numerator will be x minus x0 equals 1 minus y0 equals z minus z0. And what goes in the bottom is f sub x at that point, f sub y at that point, f sub z at that point. You need to walk around saying that. Or if you really don't want to do that, fine, but that's what you should do when you study. Don't just do millions of problems. I have so many students come up to me, and I believe them. They're like, I did every problem in the book, and I still failed. How can I do every problem in the book and still fail? Well, what they were doing was maybe they had the notes in front of them, or they had a workout example in front of them, and they kept modeling the problems after that example. And one by one, they were getting them right. They're great students. They never make any mistakes, except they came into the test not having memorized those steps. When the steps are in front of you, fine, you can do them. But what happens when they're not in front of you? I'm hoping you don't have an open book test. That's not good. Okay. Now here's another type of problem. You want to find the angle of inclination. You want to find the angle of inclination theta of the tangent plane to the given surface at the indicated point. So you're given a surface, here it is, 3x squared plus 2y squared minus z is 15, and you're given the point 225. Now, what's going on is the following. Of course, that's the z-axis, y and x. If I have a vector and I use this vector, and I know what that vector is. That vector is 0, 0, 1. That is, it's just k. It just goes in the k direction. I can find this angle. But to be honest, I want that angle. So, you know, if this angle is 20 degrees, then that angle is 20 degrees. They're complementary. So we're going to use the k as one of the vectors. So we know that the cosine of an angle between two vectors is, well, we want the normal vector times their k vector. That's this vector here. And we divide that by the length times the length. Now remember, they said to find the angle of inclination theta of the tangent plane to the given surface. That's why we can use the normal vector. Now, the normal vector is just the gradient of f, dotted with the k, divided by the length of n. But what is the length of k? The length of k is 1. And after all, 0 squared plus 0 squared plus 1 squared, square root, that's 1. So we don't even have to do this. So that kind of comes for free. Okay. So the next thing we have to do is define what f is. Just bring the 15 over. F of x, y is z. This is 3x squared plus 2y squared minus z. Take away 15 is 0. So the gradient of f is, again, there's only one component or one term that has x. Its partial is 6x. Only one component that has y's, positive 4y. And one term that has z. Its partial is negative 1. So now the gradient of f at 2, 2, 5, well, 6 times 2 is 12, 4 times y is 8, and negative 1. That's the gradient. Okay, well, we want the length of it as well. Actually, here I should have the length of the gradient. The length of the gradient. The length of the gradient, this is going to be 12 squared plus 8 squared plus 1 squared, the square root. 12 squared is 144, 8 squared is 64, 1 is 1, looks to me like 209. So it's the square root of 209. Okay. So now I want to dot these two vectors. Remember, the k vector is 0, 1, 1. So it's 12 times 0, which is 0. Remember, I'm dotting it with 0, 0, 1. 12 times 0 is 0, plus 8 times 0 is 0, plus negative 1 times 0. That's negative 1. Divided by the length. All this is negative the square root of 209 over 209. That's what the cosine of theta is. Okay, so let me get rid of a lot. That's the cosine of theta. So therefore, theta would be the cosine inverse of negative the square root of 209 over 209. This happens to be about 93.9664. So our answer is actually, we want them to add up to 180. You subtract that answer from 180 and you get the answer. The answer is it's 86.0336 degrees. It's because we found it off the y-axis and we really want it off the x. We found the angle off the z-axis. There is your answer. That is the angle of inclination. Theta is equal to that. here we have two equations. We have that x squared plus y squared equals 5, and z equal x, and one point of intersection is 2, 1, 2. X is 2, y is 1. 2 squared is 4, plus 1 squared is 1. 4 plus 5 is 5. And z and x are in fact equal. Now, we want to find the symmetric equations of the tangent line to the curve or intersection of these two surfaces. We want to find the symmetric equations of the tangent line to the curve of intersection. So find symmetric equations of their tangent line to the curve of intersection of the two surfaces. Curve of intersection of their two given curves. That is called part A. And if that's not enough, we want to do more here. We want to find the cosine. Actually, we just want to do this. So the first thing that you should do is the following. Define f of x, y, z to equal this, where we bring the 5 over. X squared plus y squared minus 5. Well then, fx is 2x and fy is 2y and fz is 0. And at the indicated point, x is 2, 2 times 2 is 4, 2 times y, when y is 1, 2 times 1 is 2, excuse me. And when x is 2, y is 1, z is 2, 0, couldn't care less. Okay. Now, we do the same for the other equation. G of x, y is z. This is, bring the z to the other side, get it equal to 0. X minus z is 0. Well then, g sub x is 1. G sub y, that's 0. And g sub z is 1. And since these are not functions of x, y, z, even at this point, g sub x is 1, gy is 0, g sub z is 1. So, on that note, we have that the delta, the gradient at 2, 1, 2 is 4, 2, 0. 4, 2, 0. And the gradient of g at our famous point is 1, 0, 1. Now we want the tangent plane. We want the equation in symmetric form. We want the equation of the tangent line, the equation of the tangent line to the curve of the intersection doesn't matter, but I prefer to write it this way, of the given surfaces. Okay. So what we want to do is, it's a good problem. I guess what we want to do first is find the cross product. We want to find delta F cross delta G. I, J, K, delta F is 4, 2, 0. Delta G is 1, 0, 1. And this determinant, I think I can do it in my head. This determinant is going to be 2I negative 4J negative 2K. So if you do the spaghetti method, that's what you would get. It's 2 times 1 negative 2 negative 1. Remember, the point is 2, 1, 2. The numerator is going to be x minus 2 for the symmetric equations, y minus 1, z minus 2, and the bottoms are just going to be from the cross product, 1, negative 2, negative 1. You can put the 2 down, it won't do much. You can put the 2, you can put down 2, negative 4, negative 2. And the reason is because this equals t. Okay? Now, if I had x minus 2 over 2 equals y minus 1 over negative 4, z minus 2 over negative 2. I really can't say this is t, because 2t should equal x minus 2. But we have 1t equals x minus 2. The big difference is the t in the second one, the t in this one. It's not t. Remember, t is any number. It's really t over 2. So now, 2 times this is t equals x minus 2. Negative 2 times t should be y minus 1. Well, negative 4 times t over 2 is negative 2t. And that equals y minus 4. So you can get away with, I'm over here now, right over here. You can get away with ignoring that 2. You scaled it down. You got smaller numbers. Okay. And that is the equation of their plane. That's the equation of the tangent line to the curve at the point of intersection. Okay, now, what if we did want to find the angle in between these two vectors, delta f and delta g? Okay, you would basically just use the formula that we've had before. Okay, so we want to find the cosine of the angle between the gradient vectors at that point. We want to find the equation, we want to find the angle between the gradient vectors. And the gradient vectors happen to be right here in red. So the cosine of the angle would be, in the numerator, it's the dot product. It's the dot product divided by the length. 4 squared is 16, plus 4 more is 20. Square root of 20. 1 squared plus 1 squared is 2. Should be times. So in the bottom, we have the square root of 40, which is 4, the square root of 4 times the square root of 10, which is 2 square root of 10. In the numerator, 4 times 1 is 4, plus 2 times 0 is 0, plus 0 times 1 is 0. We just have 4. And 2 goes into 4 2 times, so we get 2 over square root of 10, which is 2 square root of 10 over 10. That's the angle in between. That's the cosine of the angle. So the angle would be the cosine inverse of 2 square root of 10 over 10. And then you find the supplement of that. Now actually that's not true. That's not true. That is the angle. Because now we're finding the angle between two vectors. We have one vector, we have another vector. We can find the angle in between them. Okay, so that was a fun problem. Go into your exam knowing how to handle each of these problems. To go into the test knowing how to answer only half of them, if you don't make any mistakes, any simple mistakes, then you're only looking at a 50, which of course is not a good grade. And it's not even a passing grade. That's how bad of a grade 50 is. It's not even passing. You don't want to settle for a failing grade. Okay, a few more problems. Actually, one more. Find the point on the surface where the tangent plane is horizontal. So you're given that z is equal to 3 minus x squared minus y squared plus 6y. And again, you want to find a point on the surface where the tangent plane is horizontal. And this is a very simple problem. Z sub x is negative 2x. Z sub y only comes from there. It's negative 2y, excuse me, plus 6. And this equals 0 when x is 0. I want it to be horizontal. I want zx and zy to be 0. This equals 0. Well, this should be negative 6. So then 2y should be 6. That happens when y is 3. Negative 2 times 3, negative 6. You add 6, yeah, you get 0. Okay. So we have x and y. Just want to find z. We want to find z of 0 is 3. It's 3 minus x squared minus y squared plus 6 times y. It's that number minus that number minus that number plus this number. 18 plus 3 is 21 minus 9 is 12. So the point that we're looking for is 0, 3, 12. That is the point on the graph that has horizontal tangent plane, where the tangent plane is horizontal. That finishes this section. Good luck with it.